So we had completed the first case study. Okay, now we're going to move on to the second case. And in this case study, we have a little setup to complete to get this set up to do the rest of the little studies that we're doing. Okay, so this was run for you already. We don't have to run it. It was run as the Oracle count as part of the setup to prepare things. We just wanted to show you what they had done. So they'd gone to common mistakes, logged in the database, and created this new user CM. And this is the one that we missed telling you to create the connection in SQL Developer, because we're going to use that for the rest of the practices. Gave him some privileges, made him all powerful, made him a DBA in the database, so we didn't have to give him too many individual. And then we dropped a bunch of tables that he had, and then we loaded a group of tables. Okay, so they're just doing some general setups. And then they created the job history. And then they did it in the loop and loading some funny data in it. And the whole purpose was to have a little bit more volume of data than the things we would normally get from the HR schema, just to have more volume so that the queries look a little different. So it was already done. We just wanted to be upfront and showed you. So now we wanted you to create the connection to the SH. So this is what I had done earlier. And we had included it here, not at the beginning. Okay, and then what we wanted you to do is connect with that user. I had done it earlier on. Okay, and then within that session, set the timing on and flush it, so have a connection. So we'll go back to our SQL Developer environment and do that. I'm going to get rid of these things that I were working on. I don't need them anymore. It will ask you sometimes if you want to save the script files, and I don't, if you made changes to them. And then we need to go to the connection tab. I've already created my user, okay? And then what we're going to do is create a workspace for him so he can do things. So I'm just going to create a new workspace so we can do some work with him. And then what we want you to do is set the timing on and run the flush in this. So we'll just type it in. Okay, and then we want to flush it. Make sure I get it in lowercase this time. And I believe they just asked us to run it at the top. And I leave it in the script file so we can actually use it in the future. Okay, so I just execute it from the CM account. So we'll go ahead and execute that. I could have left it until we did the next piece, but we'll execute it from here. Just run it as a script file, get it to do the two pieces. Give us a little more space just so we can confirm that it did it. You can adjust it. It makes sense in your environment. And then the next thing we want to do is have a look at our join conditions. Okay. The second case that you'll analyze is a join condition, CM under connection. So we had to open that, and this is their SQL statement. We can pull it from there. What they did is just pull it up from here, and then you can cut and paste. So it's just another way of doing it. So let's take a look at that. I like to look at alternatives. So in our files, since I've gone to get to the connection, I flip back to this one. And the file they're actually looking at is the join SQL. Okay, we're going to explore just one version of a join where we're joining the job history to the employees table. And we could have just cut and pasted in, but I just wanted to show you how to load it, so we'll find that file. Over on the right side, there we go, we have the join. I can open it. It will put it in another tab. I can cut and paste from here. I could have changed it to run from here, but I just find it easier to have a couple up so I can compare it. Put another line in and paste it in. And then I can get it just to execute this one statement with the first one. We've already flushed things, no sense in flushing it. So this time it returned a number of rows. If you actually accidentally do this against a HR instead of this one, you get quite a few. You only get about 10 rows returned. This one's got quite a bit more records set up in it to make it a little more interesting. And this took to execute this particular statement. And whoops, once again, it didn't put the whole thing in, so I'll do it as a script file to get our timing. It took for the whole thing this time, because it did everything, just a little over 0.8 seconds. Just for this statement was just a little over 0.55 of a second. These are in 100ths. This is seconds, minutes, and hours. So hundredths of a second. So 55 100ths of a second to execute it. Okay, and we want to take a look at the query and what are they doing in the query, okay, that might influence the access paths and how we might join. Remember, there were 3 ways to join, and we talked about a little bit is that we could do a hash join, which would force us a full table scan on each side. Or we might do a hash join with some indexes path access, which would be cheaper than an index scan. Or we might do a nested loop. And all we're doing is just using the elapsed time to see if we can measure performance. And the thing they're doing that might be problematic if we're using indexes is this substring function on the left side of the equal sign of the join condition and on the right side. If there are indexes on the employee ID on either table, we just guaranteed that they wouldn't use the indexes. So I would bet it's doing a full table scan. One of the things we could do is remove those substrings. So let's see if that's what we do in the better join. We have a second copy of the join, and just to make sure that we're following along. And notice their timing is different. Looks like I've got a little bit better thing, but I do get their number of rows. Okay, then what we want to do is there is a better way of doing it, which may be removing those stub strings. So we'll have a look at their alternative version they came up with as a solution. The one that we were hoping you would notice. So we can go and find the better join, load it. And what I like to do is be able to go back and forth between them. So what I'm going to do is create another SQL Plus session from the CM user that we're using in this area. Okay, so I have the original one and one with the tilde 1 on it to indicate it's the second one I created. And then I'm going to load this, and then I'm going to cut and paste it. I find it the easier way, just control it. Okay, so we want to put it in there, but before we do, we want to level the playing field, set timing on, do the flush. It's a SQL script file. You need to put the add-in sign. You can also put the plus SQL. Usually I don't, but just to make sure everybody's comfortable with that, it is an SQL script file. I threw it on this time. And then I'm going to take the better one and paste it into it. And then run the whole thing. Of course, you could do it in bits and pieces if you wanted. Sometimes if I'm in the right mood, I do the flush from a different session. The timing I always have to do from this one, but I could flush it from another session. So it's going through and executing them. And now, once again, we'll just make this bigger. It tends to shrink it. Okay. Whoops, I grabbed the wrong script file. Sorry about that. Better join. We got too many better things here. Open it. There you go. That's why I had a different number of rows. I recognized it. It was wrong. So we'll just replace the SQL. No problem. Sometimes we make slight errors doing these. So everybody does that once in a while. So we'll just go back. And we'll execute it from here again and get it to do everything again. Okay, now we get the same result we had before, but now we see a reduction in time. We're hoping anyways. So to compare it, the original one took 0.55 of a second, or 55/100th. The better rewritten one, okay, without encumbering the employees with the substring function on both sides, so it opens up indexes, took less time. So we could actually tell that from the execution plan. Where there is a second way that they don't explore in the practice, but just to let you know, and we're going to look at these later, but up here there's a couple of icons. One of them allows you to run AutoTrace and one in the explain plan. And we'll discuss both of these, but if you look at either of these, it will actually show you the execution plan. Whoops. And I got something highlighted again. It gets a little interesting when you highlight things with this. There we go. And once again, we'll bring it up a bit so it's a little more readable. Now it's showing you the execution plan and the way it did it. So this one, the original run, it was able to do a fast full index scan on one side, and then it did a hash join, and it did a full scan on the other side. And then it had to sort. When I look at this one and have a look at this execution plan, so I'm just going to try something different, highlight the whole thing, and build that execution plan. It did this one as a nested loops using a couple of indexes. So it opened up both indexes were available for it, and that's what allowed us to have the reduced time. We can tell it from the time, but if you're curious what it's doing in the execution plan, you can go and have a look at it by looking at the explain plan. You can also do the AutoTrace. The main difference is explain doesn't execute the statement at this time, just builds the execution plan. AutoTrace actually builds the executes it as well as builds. So it will give you some runtime stats that can sometimes be useful also. So back to have a look at the next case. So we had a look at why it was faster by taking away the wrappers around the employees, so it opens up two indexes. And we didn't see quite the exact timing, but we did see the decrease in time, which was really what we were going to do. Next up is the third case. So before we do this, they want to flush the environment. I have them set up as part, but we're switching to the CM connection. That's what I was using. I've got it set up in the script files, so we'll just continue to use those. And this time we just wanted to have a look at, instead of putting a function around it, what happens if we change the type of data we passed it. We talked about that as an issue. If it has to do a conversion and it converts the wrong way, it may not be able to use an index. So we have a simple predicate, and we want to test this and see how long it takes it to execute. So since they gave it to us right in here, I can cut and paste this. Okay, and we're going to do it within the CM connections. I have two of them. I keep the two of them because I can do side-by-side comparisons. Makes it a little more interesting then. So I'll put the first one in. So I'll go back to the first one, replace the select statement, put it in, make sure I only have one colon. I missed it. And then execute the whole script file. And I want to see the query results. If it doesn't flip to it, which it did, we can always flip to it. And it gives us the timing that it took to execute this statement. Okay, it took 0.759, getting close to a little over 3/4 of a second. Okay, well, let's have a look at the second one. We're going to execute it in this, and we'll go find their second select statement. Okay, so they have a version of fixing it. They want you to flush it first. And you can either use the file like I did in the last one, or since they actually put it in here, we'll have a look at this one. Move it over. This was my second connection. Replace the select statement. Just paste it in. Execute the script file to get everything flushed and the latest information. And this was a substantial reduction. We moved it by an order of magnitude. It's now just a little less than 0.03 seconds, 0.026. Okay, so we saw, and the main reason is that we were trying to give you a hint with the column name. This is character data. When we entered the first time, it's the same column, it's still character data, but we did it as a numeric value. It has to convert it. If it converts the wrong way, it may not be able to use the index. This we gave it the real date, so if there was an index on the order ID, it can use the index. And once again, checking the explain plan would actually confirm it if you're interested in doing that. Okay, next up, okay, is having a look at another case. So we saw a nice reduction like they did. Okay, so once again, they want to flush it. I just like using the two screens because it allows us to do a side-by-side comparison. I just find it convenient. You can do it whatever way it makes sense if you happen to be doing these yourself. And this is examining the difference between a union and a union all and how they perform. So the first one is our union all. We're going to put it in the first one. Back to our SQL developer. Go to the first one I picked up. You try to use them consistently. Paste it in. Execute the whole thing as a script file to get our timing information and how this runs. So we end up with about 1 million rows, if I count the zeros correctly. And it took us just a little over 1.5 seconds to execute this. Okay. Now, how could we do it? If we weren't worried about duplicates, the union operator, when you union two results together, it removes duplicates, and how it removes the duplicates is by doing the sort. If we can accept a union all, or what really works nicely, if you know because of your data in your application, when you write the code, if you know this particular statement doesn't have any duplicates, then we can do a shorter operation by not doing the sort. By doing a union all, which avoids the sort, saying I'm either okay with having duplicates so I know there won't be any duplicates. If there are no duplicates, both return the exact same results, but the second one without doing the sort. So let's go grab their version without the union, with the union all in it. So they looked at their results, look similar to ours, but slightly different scale, because different machines. And then this is the one with the union all. So if we know there were no duplicates, this could be a very good solution to reduce the time it takes to process the query. If there are duplicates, then you got to worry about how much duplicate. Can the application handle the duplicates? If there's enough duplication, what we gain in avoiding the sort, we might lose in network traffic. So sometimes you have to look at the big picture. Okay, so we'll run this in the other one so we can do for side-by-side comparison. I just find it a little easier to do it that way. Execute the whole script file to get it all run, and then we see a reduction. This takes 0.133. The original one took 1.5 seconds. So we moved it a couple of orders of magnitude in reality. So a very nice improvement. And it returns the same number of rows, so there were no duplicates. So this would be a good solution for an application. And it's all about how you write the SQL with this chapter, okay, this lesson. So back to our practice guide, and they saw a reduction also. Okay, next up is case 5, combining SQL. Okay, we have a script file that does a group of SQL statements, and we're going to run this in the CM connection. So we're going to load this one up. Okay, so let's go do that. First thing I'm going to do is get rid of these that we used in the past, just simplify things. And then we're going to go find the multi1.sql. I believe that was the first one we want. Oh, this was the multi-setup. Okay, we needed to execute this. So this is a script file, so we can load the multi-setup. So I forgot we had that setup file. So just above 1, we have the multi-setup file. We'll load this, open it. Okay, and since we don't really want to time these or flush things, this is just doing the setup from it. I'm just going to run it from the CM connection out of this original one, and then I'll remove it from the screen just to simplify things. Though it still had the timing on, but what we wanted to do is get this setup done. And what I want to do is just make sure that they did multiple things. Yep. Wanted to make sure they did what they did. By keeping it too small, we tend to hide things. Now that we got this executed, I can close this because I don't really need it again unless I wanted to look at it. And if I needed it, I can always open it again. And now we have the first version of this, okay, that we actually want to run. And what we want to do is do the flush and turn the timing on this, so that we're just add it to the front of it, and I can run it. You could run it in another session. I'm just showing you some alternatives. Because these are longer multiple statements, I don't bother cutting and pasting. I could if I wanted to. But I could always just do set the timing on. Okay, and then hit the flush. With or without the SQL statement. And then just run the whole script file. Get it to execute the whole thing. Going to use the CM connection. I didn't pick it. If I don't pick it over here, it will ask me, sure. Let's go for it. Doing multiple things. And what we're interested in is the overall timing. We're doing multiple select statements, and we've actually got the individual timing. They all take on these about 0.002. Interesting enough, I tested them a little while ago on another machine, and it took 0.003. Their numbers, my numbers, on another machine all differ. That's normal expected behavior. What we want to know is, can we do this more efficiently? We wrote them as a group of individual select statements. Is there a way of combining them? And we had to look at some options in doing that. So let's look at multi-select 2, and we'll just go through. So they went in and did their setup. So we had seen that. And then we went in after they completed the setup. Okay. They went in and started to open the multi-1 like I did, and ran it. Okay, and what we were interested in, the overall timing. Okay, I turned timing off. They have it turned on in the script file, but I wanted to flush it. Okay, they turn it on and off in the script file, so I guess I could have left that off. Okay, and then we wanted to have a look at another variation, so we'll load the second one and see how that run, where we basically rewrote it as one statement using a case statement within it. Sometimes decode helps. Case gives us another alternative of combining statements together. So let's have a look at doing them as one if it has an improvement in the performance overall. So back to the SQL Plus, grab multi-2, open it. Just to make sure we load the playing field, I just put the flush on the top because we discovered I really didn't need it. And then just execute the whole script file. And then we can go back and do a side-by-side comparison. So when we rewrote it as one statement, it now took 0.018, which we go back to the first one, is an order of magnitude faster. So we did improve it by reducing the statements and being able to rewrite them as one. We did get a nice increase in performance. Okay, so we saw a similar result that they did. Numbers are a little off, but what we're looking at is the reduction. The case 6, which is the last one, is looking at database managed, database connection. What we're going to do is go back to the terminal session, and we have 2 script files that we're going to run. We actually show you the script files in the practice, so I'm not going to bore them. It's a good idea to understand. Okay, and what we do is we have a script file that goes through and loops through and executes one SQL statement by calling SQL plus multiple times. It requires a new connection to the CM each time. And we want to see how that performs, and then we want to consider a performance. So we're going to do this from the terminal session. I had one out there. What I really need to do is just go grab the name of the file. I'm already in the common. If I re-CD to it, it doesn't hurt, but I don't want to spend the time doing it because I'm already in there. And we're going to execute this one and observe the behavior. And it's going to take a few moments to run. And what it does is print out the time at the beginning and print out the time from the operating system at the end, so we can go and see what the elapsed time, just like we were doing in the rest of the ones we were testing from SQL Plus. And this takes a moment or two, because we have a nice big loop in there. It's looping through and connecting a number of times. And so when we completed executing it, okay, it took 27 plus there was 3 to tick it over the next 100th of a second. So it took us about 30/100th of a second to execute the script file. And the question becomes, is there a better way of doing it? And of course, it would be much better, okay, if we actually connected once, okay, instead of connecting in a loop 500 times, and then executed our SQL statement, whatever we want to do, the number of times. All we're removing is the multiple connections. And we wanted to demonstrate that this is, if we do it this way, it emulates what connection pooling. We have a set of connections that are pre-started for the data source for Java, and then we just reuse them. If we don't have connection pooling, every time we execute an SQL statement, it has to create a dedicated server, execute the SQL, and it shuts it down. So it makes it, we think, a lot less. The proof is in doing it, so we're going to execute the better way of doing it now and see if it really was better. So run the better shush. We're in the same directory. And now it took us less than 1/100th of a second to execute. So we went from 30 seconds to 1/100th, doing exactly the same set of SQL, except now we're doing it with one connection versus a whole group of connections. So much, much more efficient to do it this way. Okay, so the first group loops 500 times, doing 500 connections. The second one connects once and executes within its SQL script file, executes the same SQL statement we were doing before. It executes it 500 times in a loop. Getting rid of the connection saves a lot of time. And that was the end of practice number 4.